All right. Oh, sorry. All right, my friends. 2012 problem 5. It says the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it is first weighed, that is, then dB dt equals 1/5 times the quantity 100 minus b. Let y equaling b of t be the solution to the differential equation above with the initial condition b of 0 equals 20. And then for part A, it says, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. So what I would do for part A is compare the rate of change at which he's gaining weight at 40 grams to the rate of change at which he's gaining weight at 70 grams. So I'd just compare dB dt at b equaling 40, which if you just put 40 in for b, so you'd have 1/5 times 100 minus 40. So you got 60 divided by 5, which is 12. Compare that to dB dt when b equals 70. So that would be 1/5 times 100 minus 70. So you've got 30 divided by 5, which is 6. So let's see. Should I put units of measure on there? Honestly, I don't feel like I have to, but I will. So that would be grams per, what was it, day? Okay. So I would just, you've compared it. You got this number's higher than this one. So therefore, the bird gaining weight faster when it is, or when it weighs 40 grams. There we go. Okay, moving on to part B. It says, find the second derivative of b with respect to time in terms of b, and then use that second derivative to explain why the graph of b cannot resemble that graph right there. So for part B, first I'm just going to point out that this is equal to ddt of dB dt. And I'm showing more steps than you'd need to, so feel free to do this in your own way. And that would be the same as ddt of, and then I'm just going to put what they said dB dt was in there. So okay, up to you for how you want to do this derivative. It does simplify it quite a bit if you multiply the 1/5 in. Remember, b is a function of time. So when you take the derivative of negative 1/5 b, you'll need to make sure that you use the chain rule. So ddt of 20 is 0. ddt of negative 1/5 b would be negative 1/5 times dB dt. The reason we're not done at this time is because in the directions it says they want the second derivative in terms of b. And right now this is in terms of dB dt. So I'm just going to substitute what they said dB dt was. So dB dt was given as 1/5 times the quantity 100 minus b. And then, you know, if you want, you could call this your answer, or you could simplify it a little bit. I think I like writing it like this. So many different ways that you could write that. But there you go. Okay. Now, they want us to explain why, if this is the second derivative, why is it that this cannot possibly be the graph of the function? Well, what does a second derivative tell you about a function of something called b? Here, it would tell you concavity. Well, this graph, it looks like it's concave up. This is b, everybody. It's concave up from b equaling 20 to, to maybe like b equaling, let's say, it looks like it's like halfway there. So maybe b equaling 60. And then it's concave down from 60 to 100, from b equaling 60 to 100. Oops, my goodness. There we go. So let's look at, you know, what would this tell you the concavity is, you know, from, you know, let's say from 20 to 100. So your second derivative, because you've got a negative times another factor, your second derivative will be negative when this factor is positive, because a negative times a positive is a positive. So just a note, will be negative when 100 minus b is positive. So if you were to solve, you know, for b, that would mean when b is less than 100. So what is this telling me? It's telling me your graph is going to be concave down for all the b values from 100 and down. So from 100 and down, your graph should always be concave down. But it's not always concave down. It's concave up at first, and then it's concave down. So, so I would just say, according to the differential equation, the graph of b must be concave down for all b values less than 100. But the graph shows that b is concave up for, and then I would approximate that it's concave up from 20 to 60, b being from 20 to 60. So I'll just say approximately b from, just say 20 to 60. There we go. Okay, moving on to part C. See if I can find a piece of blank paper. Okay. Because I remember part C, I needed a lot of room. Probably because I write super big. Okay. Part C says, use separation of variables to find y equaling b of t, the particular solution to the differential equation with initial condition b of 0 equaling 20. So with this, you're going to see me get the general solution, and then I'll use the initial condition to get the particular solution. So I'm going to copy dB dt equaling 1/5 of, actually I'm just going to, yeah, sure, 100 minus b. And then I'm going to separate variables. So the way I did that, and you can do this a couple different ways, I'm going to multiply both sides by 5 and then multiply both sides by dt. So I'd end up with 5 dB equals 100 minus b dt. And then I'm going to divide both sides by 100 minus b. So I'd have 5 over 100 minus b db equaling dt. And at that point, I have separated variables. I would then integrate both sides. Remember that there's an invisible 1 in there with the dt integral. Let's do the easier side first, the right side. So we'd end up with t plus, I'll go ahead and say plus a constant. And then for the integral on the left side, actually I'm just going to copy it. I'm going to pull the 5 out actually. We'll call that a step. How about that? Pat myself on the back for that one. So on the left side, I'm going to let u equal 100 minus b. And then my du would be negative db. So if I put this one on the left in terms of u, I'd have 5 times the integral, actually negative 5 because of the negative db, times the integral of 1 over u du. And then now I'd have negative 5 times the natural log of the absolute value of u, which let's back substitute right now. U is equal to 100 minus b, plus a constant like that. Now that we have the antiderivatives done, now we're going to solve for b, starting with merging the constants together. So I'd have negative 5 times the natural log of the absolute value of 100 minus b equals t plus, and I'll call that my third constant. Now I'm going to divide both sides by negative 5. And a constant divided by negative 5 is now a different constant, so I'll call it C4. I'm going to exponentiate both sides, so I'll have e raised to the left side and e raised to the right side. E will undo natural logs, so I'd be left with, now on the right side, I'd have e, and then negative t over 5 plus that constant would be the exponent up there. So simplifying the right side, on the right side, using properties of exponents, this would be the same as e to the negative t over 5 times e to the c4. And then e to a constant is a new constant, so we'd have c5. So we now have c5 times e to the negative t over 5. And I'm going to bring the left side down like so. Okay. Now I'm going to yank off those absolute value marks right there, and then what that causes is a plus or minus on the right side. But since C5 has not been decided yet, in a way it's going to kind of absorb the plus or minus. But I'll just go ahead and call it C6, so I'll just make a note. C6 is either equal to positive C5 or negative C5 as needed by the initial condition. Okay, so 100 minus b then would equal plus or minus C5, which I'm going to go ahead and just put C6 in there for it. Like that. And then I like the idea of adding b and subtracting the C6 garbage over. So then I would have b in terms of time, and it would be 100 minus that sixth constant times e to the negative t over 5. So this would be the general solution, and then now you're going to see me use the initial condition to figure out what this constant is. So you're going to see me use, I'll use a new piece of paper here. You're going to see me use the fact that b of 0 was 20. So b of 0 would simply be 100 minus C6 e to the negative 0 over 5. So e to the 0 is 1, so, and this is 20. 20 would equal 1 minus C6, because since this is equal to 1. So what would C6 have to be? It would have to be 80. Oops. And then now you just take your constant that's based on the initial condition, and you just back substitute it into your general equation that you had there. So you'd have B of t, then the particular solution would be 100 minus 80 times e to the negative t over 5. There we go. And I'm pretty sure that's all they asked us for. So I think we're done. All right, my friends, I hope this helps. And feel free to contact me if you still have questions. Take care, everybody.